All right, my name's Harry Smeenk, and I appreciate you coming out this evening. What I'm going to talk about is Internet of Things in specific relationship to buildings. So I know a lot of you are in different areas, whether it's transportation, logistics, but my focus is strictly on buildings. I'll show you how we got there.
Oh, I clicked your slide.
No. Still up?
Yeah, I was trying to.
It's got to go down.
Yeah. Oh, I see it. It's on this one.
I have control over this. Is this what you're trying to?
That's
press?
fine.
Yeah.
Oh, you're.
Oh, yeah.
Oh, it's on
I have
yours.
control
Yeah.
of that.
That's why we keep
Just the
Thanks.
one line.
All right,
I
so
thought it was on his.
many, many years ago, if anybody ever watched the TED Talks, right? There was a TED Talk on how to do TED Talks. It was hilarious. And the first thing it said is, you gotta start off with something memorable. Right? So throw an image out there, but it really has to be tied to a number. So 1.5 billion. So that's what the TED Talk diary says what you're supposed to do. Then you're supposed to throw another number out there, 3.25 billion. You go, okay, great. What's all that about? So the 1.5 billion is how many IoT devices are currently in commercial buildings. And I stress commercial buildings because there are a lot more buildings than just commercial buildings. And the forecast for 2026, I'm sorry, 28 is 3.25. So a growth rate, a compound annual growth rate of over close to 14%. I think these numbers are actually low, but given where the industry is right now, it may have actually worked out. Which building system inside a building do you think has the most IoT devices? Any guesses?
Security.
Air conditioning. Security is the winner. Security and access has the most IoT devices, expected to grow at about 12%. And then somebody else said air conditioning, so HVAC is number 2.
Both of them are wrong. Data centers, number one.
If the building has it.
By no, by
If the building has
definition,
it.
every endpoint in there that's connected is a freaking IoT device.
So from a market perspective, what's going on with the market? So look at the US, we've got 5.8 million buildings, which equals about only 87 billion square feet. So back to that, throw out big numbers. The number of people that are engaged in the industry. So when I was writing the book, that's my target audience. I said, all I need is 1% of these people. That's 26,580. But we're not going to get 1%. The overall market for the next 10 years for smart buildings looking to grow at almost from 70 million, almost doubling, or more than doubling, to 201 million. 33% of commercial real estate buildings still, as of a year ago, that's the latest data available, is still using manual tracking devices for managing the assets in their building, managing the assets of their building. So now here's the problem. So over the past couple of years with COVID and the hybrid working environment, and a lot of companies not going back, this industry has stalled. Right now, it's basically doing nothing. The problem is a lot of leases are coming up over the next year, next 2 years. A lot of companies are saying, I don't need that much space, I don't want that much space. So from a building industry right now, it's hard to move a product. So we're suffering. We're seeing some in an effort to bring people back into the buildings. We're trying to push indoor air quality, occupancy sensors, and that sort of thing. But generally speaking, building owners right now, building managers, are in a wait and see mode because their number one priority is to keep those leases going. So building types. When you think about building types, I mentioned commercial buildings, but really there are tons and tons of different buildings, put them in categories, data centers, education buildings, hospitality, the list goes on and on. So when we're talking about smart buildings, we're talking about any one of these particular buildings. And that even includes event centers where stadiums, theaters, auditoriums. So we've done a lot of work at Cowboy Stadium with the 5G network out there. It's funny, they actually had AT&T 5G, and it wasn't 5G for up until this year. How are we supposed to know that? So smart building, all kinds of different definitions, TIA, which Jacques is part of, I used to be part of it. We had a fancy definition, but keep it simple, it's really integrated set of technologies and systems used to manage the building. You want to optimize performance, you want to increase the satisfaction of the people in the building. Those are really the primary goals. Buildings are systems of systems. So when you look at a building, there are many different systems. I'm just gonna go through all these, but sorry. So you got civil, you got mechanical, which covers elevators and escalators, chillers, all kinds of pumps. You got technology systems that are running the building, doing the data management. You got the plumbing systems, you got energy systems, electrical. So when you look at a building as a whole, there's quite a bit of opportunity for Internet of Things and for smart building applications. So almost every one of these items, you could put an IoT device or sensor on it, and it becomes technically smart. This is what it looks like in a non-chart format or non-spreadsheet type format. Basically, you've got room controls and water system management. Shading has become very popular. Emergency notification. So a ton of applications, and I'm going to go through a list of applications that I've covered off. With buildings, it's important to start by recognizing who the key stakeholders are. And there are a ton of stakeholders when it comes to a building. So you've got, the building owners. Owners may own and operate their own building. More times than not, they use a building management company to actually operate the building. They use a commercial real estate to do the leasing, to do the transactions. You've got, right now, one of the bigger problems we've got as a country is a bunch of our real estate investment trusts are tied up in buildings. If the value of buildings is going down because of the slow market, it's a trickle effect. Suppliers and OEMs, think about all the different materials and things that go into a building. And then you look at it from the local community. So why is the building there? What's the purpose of the building? It's a school or a post office or a jail or a courthouse. Right? You've got your local community and citizens involved. Whether it's a government building, a good percentage of all buildings around the country are government owned, whether it's federal, state, or local. And then you've got mechanical firms and system integrators and master system integrators, all different parts of the ecosystem that are key stakeholders. But probably the most important stakeholder, obviously, is the occupant, the tenant, the visitor, the person that's using the building, looking for that benefits of why that building exists. So anytime we look at building itself, it's important to look at who are the stakeholders and what is their perspective and what is their impact. So why IoT and smart buildings? We've covered a couple of things already, but first and foremost, building automation. So there's huge opportunities to integrate with the building automation system, the building management system. Again, putting sensors on everything allows you to capture the data, but also control the outcomes. Facility controls. So this is where it becomes important to get the data and then be able to react to the data. So getting real-time data from a sensor that says, okay, I've got too much humidity building up in this part of the building. I need to go in right now and make a change to my air dampers. Bring more air in or bring less air in. First, that's done manually, and then you can automate that process through AI by being able to say, okay, we've got history that shows when this occurs, make this change. So we're doing a lot of that these days. Sorry, I'm losing my voice because I had a cold last week. Asset management, tracking everything from computers to equipment, hospitals, medical, any building that has technology in it. You know, put a sensor on it, you can track where it's at. You can track when it leaves the building. You can track who has it. You can track when maintenance is due on it. You can put information about the vendor in with that. So like if there is a problem, you can pull up the operator's manual right there with the device. So lots of opportunities with asset management. Operations and maintenance. I don't know if I have it separate or not. Predictive maintenance and preventative maintenance, as opposed to waiting for it to break, using mean time distributions, mean time between failure data, and being able to calculate and say, all right, we know we're gonna have to change this control wrap or this fan. But also, on the other hand, we're putting IoT sensors in with air filters. And we're looking at it saying, well, that air filter doesn't need to change stuff. So benefits both ways. Space management. So right now, in this hybrid world that we're in, offices are struggling to say, okay, I don't need as much space. I've got people coming in 2 or 3 days a week. Can I somehow restructure my space to be able to lease less? Probably the number one thing for the past couple of years and even going forward is IoT systems and smart building systems tied to energy management. There's a ton of opportunity from the Biden administration, the program after program, where buildings can effectively reduce their carbon footprint, reduce their energy, give back to the grid, all different programs. But there's a ton of available benefits to building owners. Okay, so preventative and predictive maintenance. Excuse me. Metering and submetering. So you would think that submetering has been around for a long time, and it has. But it's amazing how many buildings I still come across that do not have submetering. And what's important about submetering is, let's say it's a condo, right? I want to know my specific use of water and energy, so I can manage. I don't want, I get the bill for the whole building and I get a percentage of it. I want to be able to say, I don't use the water, I don't use the lights, and I want to control my costs. So submetering still shocks me to this day. How little is used. Remote monitoring and management. I mean, the one thing that COVID did help us as an industry do is we launched a ton of remote monitoring and management. And that's still in place. Now, what's happening today is this industry is losing skill sets rapidly. And they're hard to replace because they're not going to vocational schools to get trained. It means that we don't have enough feet on the street. So we can't be sending engineers to 10 buildings to find out data. We've got to be able to remotely capture that data, make a decision, make a plan, be efficient. So it's not only COVID, but the loss of people. Optimization. So another reason we're putting IoT in the smart buildings or in the buildings to make them smart is to optimize building operations. Anywhere from the air handlers. We're doing a lot right now with a company called Brainbox out of Montreal. You're familiar with them, Jeff?
Yeah.
We're doing a lot of AI and predictive weather forecasting to actually control energy in the building based on some pretty sophisticated algorithms. And then building IoT devices, just being able to control anything and everything. The big thing, tenants that are coming back into a building, occupants coming back, they're demanding more control. They want to be able to turn the lights on. They want to control the air conditioning. They don't want to call down and wait 45 minutes for someone to come up and change the temperature 1 degree, then find out it's wrong. They went the wrong way. But also, smart parking apps, room scheduling apps. How do I know there's an available EV charging station in the parking lot? That sort of stuff. So we're seeing a lot more optimization of the tenant experience. solve building challenges. So the number one challenge, I would have alluded to already, is how do we get people back, returning to offices, returning to the building? So IoT has been huge in that space to be able to supplement that. So we're seeing occupancy sensors, we're seeing indoor air quality, probably the two biggest areas right now. Security, access, hands-free devices, that sort of thing, ever since COVID. So traditionally, the building industry has been slow to adopt technology. One fortunate thing from COVID is they woke up pretty quick and realized that they needed to get stepped unplugged. Reduce operating costs, we talked about that a little bit already. Again, the qualified resource shortage, a way to supplement that. The explosion of IoT devices, so the cost of IoT devices have come down significantly. So where 4 or 5 years ago, it may not have made sense to put in, all these devices to control, pick an item. But now those costs are down to a couple of bucks a sensor in some cases. Tenant demands and building energy management. So I wrote a book. Why did I write a book? I wrote a book because I always wanted to write a book about my dysfunctional family. And it's a long story. I have 7 brothers and 1 sister. So just imagine nightmare there. Problem is, not one of their lawyers was ever going to sign off on releasing the book. So I said, forget it. I'm going to have to go a different route. So I got approached about a year ago by a publishing company. Said, hey, you're an expert in smart buildings, IoT. There's nothing out there. Would you write a book? So that's why I got it. But there was also another reason. I came from the telecom background. I had 20 years at Nortel. I did another 15 years running wireless deployment companies. Did TIA with Jacques, where we were doing standards for the buildings. So we had that experience coming on the building side. When I got to TIA, I started working with in-building public safety networks. And FirstNet was actually being launched at that time. But it's also understanding the regulations around what's required in a building. It's getting more and more complicated. We're now, at some point in time, I think it's 26, but we've got to be able to locate a person within 9 meters inside a building with a device. How are you going to do that in a stairwell? How are you going to do that in the elevators? So that part became pretty clear. Working with buildings, there's all these guys on the IT side that are running around plugging in laptops and fax machines. And, great. That's a whole other network inside the building. Then there's these building operation technology, all those systems, right? The energy management system, the building management system, the automation system. So we've got operations technology. And then we've got Internet of Things coming in to build on top of that. So what I found out very quickly is these people don't talk to each other. They don't even know each other. They're in the same building. About the only common element they have is, hey, can I connect to your router? Can I connect to your Ethernet cable? Can I connect to your Wi-Fi? But other than that, they don't speak the same language. And worse than that, siloed data. They come from different industries, different industry associations, different standards, different language. Nobody speaks the same. So when I got involved with buildings, I had people looking at me with 3 eyes going, what's he talking about? And again, I came into it from a communications network standpoint. But I quickly learned about the other side, about all the operations technologies. And you're sitting there going, well, this is dumb. Why are we putting 4 or 5 networks in this building when we can put 1 network? And obviously there's security concerns, there's safety and all that. But the real answer is because that department head and that department head report to 2 different bosses and they never talk to each other. That's unfortunately how it usually happens. My goal of writing the book was, how do I provide information to any one of these groups, right? If you're coming from any one of these segments to learn about the other. So that was the basic intent. But convergence is happening. Slowly, very slowly, but it is happening. So the book outline, basically 4 parts to the book. The first part of the book is about applications for smart buildings. And again, a lot of what I just covered in detail there. Why to do it, where to do it, operations, first responders, tenant services, and all that. So it's given an overview. The book really starts, and I'll show in a minute, with a day in the life of, I think, last year I presented that here. Then when I go into the building architecture, going into how do you look at a project. I want to do a project in smart building. And nothing, unless you're doing a total strip down to the bare knuckles, and not making your building smart is going to happen one project at a time or 2 projects at a time. A lot of money, the price is coming down, but it requires money and it requires time to do it. So this section basically outlines how to review, how to assess, how to look at individual projects. At the end of the day, it's going to have to come down to an ROI that you can sell to management to put that solution in. And then I got to do my political correct stuff about sustainability, ESG. I hate ESG, but it talks about it's very important inside buildings for them to get those tax credits and get those carbon credits. Very specific on reporting. They can't get those reports without IoT sensors. Collect that data. So that's where it becomes very important. I may hate it, but it's an important piece of it. So I start off just about a day in the life of the building. So we got our Jetson family. Anybody here remember the Jetsons? A couple people old enough. And so you arrive in an electric vehicle, got facial recognition, open the door, smart elevator, basically says, hey, I know Jacques. He's going up to the 5th floor. On the way up to the 5th floor, his music's turned on, the lights turn out, temperature's adjusted. He gets there, drone delivers his coffee, and robots delivering supplies and documents, right? Everybody remember Rosie Robot? Then we've got Henry Orbit. Remember, Henry was the maintenance guy. Henry was lazy, so he built Mac. This is the first Mac. This is what, 1963? This is literally the first Mac. 64? So he built Mac to do the work for him. He's managing the building highlights, energy management system. They're focused on in-building coverage, focused on having enough broadband for multiple tasks. I was telling somebody earlier here a few minutes ago, I said, all my friends are mad at me right now because I have 1G at the house and when the Stars are playing and they score a goal, I'll text that goal before they even get a chance to see it. So they're like, stop. And I figured about 60 to 90 seconds faster than they are. That's the difference, fiber, 1G. And I live on a ranch in the country, with 8 acres, so it's pretty amazing. Smart windows. Anybody familiar with a company called View? I think they're owned by Corning. John probably knows. You think about every window pane, every item, every chair, every desk, almost every item inside a building is having an IP address. Being able to manage and control it. So these windows, they can tint, they can, do all kinds of energy efficiency coatings on it, readings. They can put cellular antennas in the glass where you don't even see it. So again, every one of these windows has a separate IP address. All that has to be managed. That's your smart building. And then finally, you're in your building. And when I remember Mr. Spacey was the boss man, and so he's all concerned about productivity improvements, lighting, air quality, HVAC, all those different things. His competitor, Cogswell, he was a little more sophisticated. He got, the smart conference room that had every feature in there, and how to do AirPlay, smart to capture the meeting minutes. By the time you get back to your desk or your office, those meeting minutes are typed and already presented to you. Immersive presentations, huge here. One of the projects I'm working on with a local city here is to set up their economic development corporation with an immersive display so that they can show everything that's going on in the city. There's a lot going on in this city. And then Ruby the computer, most people don't remember Ruby, but then building as a service. So basically what the book starts off with is, this is the day in the life of what it's like to work inside Smart. These are some of the things that you can come across. Talk about location services, right?
Are we done with the Jetsons?
We're done with the Jetsons.
What happened to Jane and Judy?
I guess I'm a male chauvinist. I couldn't find a use for him.
Smart cooking.
I'll leave that to you.
Smart cooking. Sorry, guys.
Wayfinding, navigation, asset tracking. So these are big components inside smart buildings right now. And there's a ton of technology, RFID cards to LoRaWAN to Zigbee to, I mean, the list goes on and on. And the book actually covers almost every one of those in detail. I'm not going to do that here, but from an application standpoint, this is becoming very popular, especially when you get into these larger buildings and hospitals. Trying to find your way around is difficult. I'm not going to go through all these, but there's a number of different building communication protocols, whether it's wireline, wireless. There's more than what's on this list. I fully recommend that. But each one of those, you got to look at what's the application, why was it developed, what are the security, what's the transmission mode, so that sort of thing. So the book does cover quite a bit of these in a little more detail, maybe a page on each one. So smart building IoT components. My company, I have two companies. One of them is TAPA, T-A-P-A, and we are an internet network building company for smart buildings. So we go in and put networks. And obviously the first thing we start with is IoT devices. So right now, indoor air quality, occupancy sensors are the big items. We install those. We have to connect those. So our solution is all about connectivity.
Are you using Wi-Fi or what are you using primarily for connectivity?
We, it depends. So we do some Wi-Fi, we do some cellular, we do some hardwire. Each customer is a little bit different. We can do LoRaWAN, we can do anything. But right now, the bigger ones are cellular. And then we're using MQTT as well.
What kind of occupancy sensors do you guys use?
We just buy off the shelf whatever our customer wants. So there's a couple of different brands. I'd have to look up which ones.
So not the camera occupancy solutions.
No, the camera ones are hard to, they're more heat sensors or visual sensors, but with the recognition's blocked out. So it's sensing the body, but it's not sensing that you can't read the face. A lot of security concerns on that. The other part of the IoT components, obviously the IoT network, are the computing analytics. So all this data that's being captured, it's got to be ciphered up as to how much of it needs to be real time, how much of it needs to be stay in the building, how much can go to the cloud. A solution that we provide, we do some of the computing on site because there's real time need. We don't have, we don't want to take the risk of an internet outage. But some of the data, historical data, will send up to the cloud. IoT devices, what I mean by this is
Have you done any work with Research Frontiers?
I'm sorry?
Have you done any work with Research Frontiers?
No. I'm not sure what that is.
It's a company that have about 600 or 800 different patents and all those different types of glass.
No, I'll have to look them up. I don't worry. Research Frontier. So back to the shameless plug. TAPA, what we do again is that IoT platform where we're building APIs. These APIs are interfacing. We put them on there. Typically, we put an edge router in the building. Unless we're doing government work, then it has to go on their server. Always a lot of fun. But it doesn't matter where it's hosted. Basically the same IoT or and from there, we have our historical data, third-party data, anything else coming from the cloud. And then we can connect to, pick a topic, indoor air quality or any one of these. That you doing that?
Yeah, sorry.
Yeah, but have a sensor, bring a sensor. So the way that we're set up is we can do basically a full stack, or we can do part of the stack. So in some cases, we have our customers will bring their devices or have their own IoT devices, and we'll provide the middleware, the algorithms, and do the middle part. They may also have their own user interface, so we're providing data to their user interface. If they don't have their own user interface, then they can use ours. It's amazing. That discussion takes months because they think they have their own, and then they realize that they don't have their own. But basically, our platform interconnected. We facilitate the exchange of information between systems, and we take that data, we integrate it, do the analytics, all real time, and then have outcomes.
Is it more like a visual platform? Is that kind of
Is that
the TAPA? Is that more of a visual thing where you bring in all the APIs together?
It's behind the scenes, so there is a visual part of it. There's a dashboard,
Okay.
and there's a user interface, but most of the analytics and the computing is behind the scenes.
Got it. So then can any system plug into yours?
Pretty much, it's open source so that we can. Like right now, we just signed an agreement with Distech Control, which is a big HVAC control company, where they're going to use our software to manage their particular product. They're only using a small part of that stack.
Can you connect the two different systems? So for example, if you have occupancy of XYZ company and then let's say you have air quality from some other or HVAC from some other company.
Yeah, so the way we do that is we use backnet.
Right.
So pretty much 70% of buildings in the US, Class A buildings, use BACnet as their communication protocol. So if they're on BACnet, then we just connect to that, and then we can get data points. We go in and we do a search, and we search down all the data points. That search can take 2 days. If it doesn't have BACnet, then our system actually can become the communication protocol. Again, we can use cellular, we can use Wi-Fi, we can use LoRa, we can pick one, doesn't matter. Hardwired in some cases. Like in DC, we do a lot of hardwiring. So we connect to the BACnet, we have our edge server, we do a lot of our API stuff in the cloud. And then from there, we offer, our solution is we're selling SaaS, and so we're selling service, software as a service, which means you can buy one module, you can buy 50 modules. And the monthly charge is going to depend on how many modules that company's using.
So is a module by use case?
Yeah, it's typically so indoor air quality would be a module. Occupancy sensing would be another module. Leak detection would be another module. Monitoring, management, like.
So a lot of the non-class A buildings, like hotels and some other things.
Yeah.
They don't have BACnet, they're usually the weak link there.
Right.
Is the property management systems that they use, which are
Horrible.
exactly.
Yeah.
And so, can kind of what's your angle there? Because
So-
you are dealing with a really
Yeah.
antiquated back.
I mean, that's the market right now that
Yeah,
I'm putting my team on 100%.
yeah,
Because we can go in there, a building management system, a BMS system.
Yeah.
With, in a class A building costs anywhere from $250,000 to $500,000.
Yeah.
So that's why they don't go in class B, class C buildings.
Yeah.
But I can put a similar network in with this edge router, this setup. Make it the communication protocol, but typically under $15,000.
so you're proposing overlay.
We just overlay it and then you don't need the BMS, you don't need the BMA.
Yeah, the BMS.
I mean, the market is basically moving away from EMS to building automation systems. The problem is they, again, just like the telecom industry, they box themselves in the corner, proprietary language. You want Siemens, you can only buy Siemens upgrade. You want Schneider Electric, you can only buy Schneider. Now, they're starting to move out of that, but they're still, in the meantime, they're getting run over by the garage. We use Google Firebase as our front end. Amazon Cloud. Trying to get that bill down, it's killing me. Well, I swear, we get it down 1 month, the next month it doubles. So there's an app for that. Chapter 11, I think. Actually go through and list almost every building application I could think of. So I'm going to tell you from the beginning, there's probably more than what's on this list. But these are some of the more common. So, bike storage, who thinks about bike storage? Who thinks about package management, which will be on the next one? Documentation libraries, EV vehicle charging, elevators. So you start looking at all these companies, put the whole list out here, see if I got it. You look at all these companies, you got individual companies showing up saying, hey, I can come in and do a gamification program. Great. I can come in and put a locker storage and fitness scheduling program. Great. You can do all that, but it's all separate applications. So what we try to do is say, okay, we'll take all those programs, we'll put them on a single platform and make it one application. Now, are we there yet? No, but we're getting there slowly. Right now, we've probably got 7 or 8 different applications, but we can add them very quickly. But when you look at a building, every one of these areas is an opportunity to put IoT devices and make them smarter. I was blown away by the number. Building assessments and certifications. So I started down this in Denver. I'm taking credit for inventing Spry. They changed the name, I don't like it, but when I was with TIA, I basically commissioned a smart building assessment program. And what it was how do we know where that building currently is in terms of how smart it is? We have to have a way to measure that. So Jacques, who's with TIA, and UL came together, call it Spry or Spire, which is the top of the building. But that program got launched about 2 years ago. Wired Score, it's been out there for a while. They've got a number of different levels. Smart Building Lead, Smart Building Alliance, mostly in Europe, if they're out of France. But they have a pretty good program that they use in Europe. Monday Live, I'm going to talk about this a little bit. This is a group I'm actually recently got involved with and actually have a whole chapter on it in the book. They are a group of probably 20 industry experts that every Monday at 3 o'clock, they get on a phone call and talk about the latest trends going on in the business. So the past couple of conversations have been all about chat. Yeah. But they've got a program as well that you can use to do assessment. So one of the things I recommend is before starting any project is get a good understanding of what's currently going on in your building. Right? Look at any one of these, they're all good programs. But figure out, kind of get your baseline. And then from there, look at what programs you want to work on. Monday Live, the people I was talking about, they kind of put a format together that says, all right, walk through it using this like logistical spread. So what's the purpose? What are the operations involved? How's it getting delivered? What are the apps that are needed? How's data being exchanged? Who owns the data? Where's the data? Where's it being managed? And then what are the systems required? And what's the physical, whether it's the buildings, typically the 100-year type of investment. So they've got a number of different ways. I'm not going to go through it here. Chapter 9 goes through it all. But using that model, you can look at it a number of different ways. You can look at it from a technology standpoint. Why am I doing this? I need to increase my broadband. I need to reduce my latency. I need to have better reliability, right? So that's the reason for doing this particular smart building initiative. And then you can walk through it. Again, I won't go bore you with all this, but it's a good format, it's a good template to walk through the process. What I did is I came up with a smart building project framework. And then under here, I've listed in the book what chapter covers that particular area. And what I realized is I didn't write a book that was sequential. But you don't figure that out until you're done. It still works, so that's why this is important. But existing system, doing that technology yourself. Developing a vision. Why are we doing this? You don't want to just do technology for technology's sake. You want to solve a building issue, you want to solve a tenant problem, you want to increase revenues, reduce costs, that sort of thing. Prioritize. One thing you'll find in buildings, if you're involved with buildings, the worst term I've ever heard is a term called value engineering. And value engineering is where projects just get cut. And a lot of that is because, well, they don't understand it. They'll tell you they don't have the money. We're going to cut that out. Right? So we see a lot of smart buildings being designed, but not a lot of them get built because they get value engineered once they see the cost. But, system selection, then looking at your partners, who you're bringing in, master system integrators, OEM vendors. There's a number of different, it's back to that stakeholder list, people that need to be involved. Cyber network security, and then how do you optimize the system, so forth, to make it fit, get it all in place. So that's kind of the framework that I've developed in the book. Use cases. So got a couple of neat use cases that we talk about in the book. Carnival Cruise Line has this IoT that they've trademarked. Basically, you're given a badge when you get on certain ships. I don't think it's all of their ships yet. And wherever you go, it knows your profile and it pops things up on your phone or on screens and says, oh, I know Harry likes whatever. I like margaritas. So it'll pop up and say, margaritas on special right now in this bar. So it's basically customized to the user. And invasion of privacy, you fill the profile out, so it's only as good as the information you put in. But it's pretty neat. When you think about a cruise ship,
And how is the response to that one?
actually it's been pretty good.
We basically tracking people wherever they go. It's a huge privacy issue.
You don't have to sign up, it's optional.
So anyone who enters the ship can choose not to opt in for the badge.
If you go on a ship and you don't want the experience, then you don't have to do it.
I'll tell you about it later.
Did you do it?
I've got a similar technology.
Oh, okay.
Cisco underwrote that because they left an executive on the board at Cabo San Lucas. So Cisco Systems actually underwrote that project with Accenture for Carnival.
I didn't know that. Interesting. Okay, so Lincoln Property, big commercial real estate company. We're doing a lot of projects with indoor air quality with them right now. So this is a sample of 101 Constitution Ave, my favorite building in the country. See the fireworks in Washington in there, but anyhow, this is just a picture of our display from the tap on device. Lowe's, we got a use case in there. But Lowe's is actually pretty aggressive in terms of using IoT. Right down to, they want to avoid, when you have a box up on the top shelf. And nobody knows, is that a green chair or is that a blue chair inside that box? They've got technology now where they don't have to move the box. They don't have to try to, squeeze around and look for the label that's always on the back. They actually have technology tied to those that will tell them exactly what it is. Now, barcodes can do the same thing, but if you're not able to get up there with a barcode. But they're doing a lot of tracking in the store. So if Jacques goes in and he buys a number of different screws, they may direct him towards a new screwdriver. Or they do product placement based on foot traffic. So there's a lot of analysis that Lowe's is doing. Sinclair Hotel. A couple of you in this room are familiar with that. This is in Fort Worth. It's the rebuild of the Sinclair Oil Building, which is now a hotel. Farouk did an excellent job. Ground up, it's all power over Ethernet.
Beautiful.
It's a beautiful building.
Yeah.
If you haven't seen it, it's worth a trip out.
It's worth staying a night there. It's pretty nice.
You can afford it. It's not that bad. But like, here's a smart mirror in the bathroom, and checking the weather, changing the music, changing. So unbelievable. I mean, anything and everything is power.
88 degree
Powered
shower, 108 degree shower, click. It's great.
They even ripped out the generator and put in Tesla batteries for
Some Samsung Powerwall, first commercial Samsung
Samsung.
Powerwall. And the
So it's
outside of Korea.
pretty impressive. Kimberly Clark, smart IoT connected restroom. So with COVID and coming back to the buildings, how do I go to a bathroom without touching anything? But more importantly, from a building maintenance standpoint, limited resources, how do I know when that paper towel dispenser is near empty? The soap dispenser, and if there's a spill. So they've got a whole solution tied around that. We talk about that use case. And then my buddies at Brainbox out of Montreal. Here's just a sample case of what they did for energy efficiency in a shopping mall in Australia. I say my buddies because we partner with them on projects quite a bit. So there's some of the use cases. Evolution, talk a little bit about the evolution of buildings. So back in the 80s, it started with local controls, pneumatic controls, basically. In the 90s, we started getting more computers, a little bit more central controlled, but direct on-off type. In the 2000s, we started seeing these communication protocols being developed and implemented. Intelligent buildings, it's a term it's used. I don't know how intelligent they are, but the focus there was green buildings, energy management. So, a lot of how do we get costs out of the building? How do we make this building green? How do we reduce carbon? All still key areas, but back in the 2000s, that was a big. Again, most of the connections were done fiber, twisted pair, Ethernet. And we get into 2015 timeframe-ish, 2020. This has been past 5, 6, 7 years. Smart buildings are out there. It's not rocket science. It's just a matter of getting them connected and getting the software program in there. And then my personal view is the next level is the unified building. The unified building is where you've got everything, all these systems, from those 5 systems I talked about at the beginning, the communication networks, all those being one network, all that information being one system. Far-fetched, a lot of risks, a lot of security, but it can be done. Technically, it can be done. So we've got a fully integrated microprocessor-based control sensors, still some IP connectivity, but a lot of wireless as well. And it's all about big data, machine learning, and artificial intelligence. So this is kind of my view of the history of how we've got to where we're at and where we're going. And I think we're
Any sense of adoption rate across time there? Where going from local controls to more intelligent and smart buildings?
Yeah, I think, we saw some pretty good adoption rates for the intelligent buildings. And it was almost a 20-year period. Smart buildings still being adopted. So it's been slow. I think you missed the first part where, right now the industry's in chaos because of COVID and, companies not going back to commercial buildings. So a lot of this is not getting done. It's a hurry up and wait. Most leases over the next 2 years are coming up. And these commercial real estate companies are more focused on how do I keep those people in there? And then I have to say something about cybersecurity. I don't know what to say about cybersecurity because I am not a cybersecurity expert, nor do I want to be. I got enough problems. So I will tell you to go follow the NIST cybersecurity framework. Seems to work pretty well.
You can reach out to the local FBI and they'll actually do a free assessment of your building. If you give them your cybersecurity plan. I just found out
I
this.
did not know that. Yeah. Interesting. So, having said all that, so you think you want to write a book? See your service does.
Yeah. Is there, they should be part of your emergency plan when somebody tries to blow it up, right?
So I was asked to talk about, right? You wrote a book, how fun was it? Would you do it again? Couple things I learned. Read the contract. When you're publishing. Don't get all excited and say, "Yoo-hoo." Read the damn contract. You'll figure out why. The outline becomes very important. Without the outline, my 5th grade teacher obviously taught that for a reason, or whatever grade that was. But you got to be prepared to make adjustments, because what happens is you go, wait a minute, I already covered that. So I've got to change this here. This is the piece that burnt me. You cannot cut and paste stuff that you've done in the past. I've written 50 articles that are out there, Forbes magazine, Smart Building Automation magazines. I was not allowed to use any of those. And anytime I tried to cut and paste, their little plagiarism algorithm thing didn't say. I said, but I wrote that, and it's not yours. You may have wrote it, but it's now owned by whoever published it. So my intention of using a lot of data that I had existing, I couldn't use.
You can use your own presentation or something.
To some degree, if they were public domain presentations, like if I presented at a conference, a lot of times I couldn't use those. This one I could use. Unless somebody goes tell me. But that's a hard lesson, because I really thought a lot of my work was already done. When you do research, write down where you found it. Because when they come back through the editing process, and you gotta go, oh shit, where did I find it? Finding what you found once before is a lot harder than finding it the first time. If that makes any sense, right? Technical writers. So the problem I had, and explained this to somebody earlier, is, well, I'm an industry expert in smart buildings and IoT, right? Unless somebody else is, I don't mean this the wrong way, but they don't understand what I'm talking about. So how can they do the technical review of my book? Frustrating beyond belief, trying to explain to these engineers what I was talking about. They would come back and say, well, we can't find any information on the internet. I go, well, that's the point. This is new data. This is new stuff. So I could have brought my own technical writer next time. I will, somebody that came from that space, because that was very frustrating. Stay on schedule. So it was 15 chapters, 1 chapter every 2 weeks, roughly about 25 hours to write a chapter. Here's the problem. From not reading the contract, the reviews take longer than writing does. And again, it's iteration after iteration of review from a publisher, from an editor, from a technical review, there's 4 different reviews. And again, you got to explain to these 4 different groups what it is, and they don't know anything. But then there's always one person that knows everything, right? And you gotta shut them down quickly and say, look, if you wanna write the book, you write the book. Otherwise, go away. So that would be my advice. Or just use chat. Unlike that kid that got caught yesterday, because he turned in a final paper in college using, somehow they picked up on it, you gotta be that zero.
You just don't get caught.
Don't get caught, yeah. So. Anybody remember this? Wayne Schneider. One day at a time.
He runs Schneider Electric, I'm pretty sure.
Yeah. He graduated. He had a saying that said, always remember, don't ever forget. Right? Again, we're showing our age. That was the 70s. So I always end every presentation with saying, the left lane is for passing. If you're new to this country, welcome. Get the hell out of the left lane. And open sources. I can't stress this enough. The number one issue in my mind that's got to be addressed, and I keep going to TIA saying you guys gotta work on this, is we don't have common language. We have common protocols, and we do have some languages out there, but we really need to focus on everybody speaking the same language. And what's happening is my engineer goes in, he codes a building, and he calls a light switch. He abbreviates it, right? Any way that he abbreviates it, another person does it different. Those two will never match it. Okay? So this common naming scheme has really gotta get going. I'm a big supporter of Project Haystack. There are a number of different systems and regulatory groups out there. This one, actually, this is from 2 days ago, or 3 days last week, this oncology alignment project is a group that's actually using Haystack as the basis for the most part. And trying to get to that common language. So I just say that this is one of my complaint points. So that is what I had. Given time. Good. Questions, comments? Yes, sir.
So you did briefly mention cameras as a sensor idea. So how do those fit? Obviously, one way would be the camera trying to come up with, tabular digital data. But what about just carrying video as an additional piece of information to other, like to events? Something happened in a room and I want to see a snapshot of what that room looked like at that time. Does that fit into this?
Oh, absolutely. Video is a huge part of all this. And that's a big part of the data. Collection of data analysis. But the problem with video is you've got to be careful on the privacy issue.
They're
So
doing a lot of meta tagging into the data now, where they just will say guy in black hat with blue jacket. And they'll send that, and then that's how they do it. So access cameras I worked a lot with, they do that meta tagging. They're used in most 5-day buildings, right? Quite a few. Right?
yeah, and security cameras are huge. When many times have we seen a crime solved? They're looking at the cameras off the building. Other questions, comments? Yes, sir.
From an academic perspective, that's because I come from academic community. What kind of skill sets required? Because the whole sensors, connectivity, IoT, you started from telecommunication as a background and grew into that. But the youngsters who are want to get into this field, what would you advise them? They should have a minimum. They cannot have it all, but minimum level.
Yeah.
So they can work in an industry like yours or something like that.
So I can write about it, but I can't do it. I don't have the skills to do it. I fully admit that. I'm not an engineer, but the skills that I have inside my company right now that is doing that. The two biggest skills are the guys with experience on building systems. So they've got 20 years of working with HVAC systems, controllers, and all the different companies, the Schneiders, the Distex, the Link Springs, right? So they understand the application. The part that they don't necessarily get is the coding of the software. So I've got a couple of software coders that understand that piece, but they don't understand the building piece. So it's bringing those together and getting those guys to actually see the problem together and then work the solution. But at the end of the day, an HVAC system is still a mechanical unit that requires it to be taken apart to be fixed. So those technical skills are still required. But everything's moving towards being connected. So where that technical engineer could fix the HVAC, used to just get away with the hardware piece of it. They've got to really know the software element of it now, and being able to, how it connects. And be able to write code that says, I need this to talk to that.
One more question, if you don't mind.
Yeah.
Framework that you've talked about, that you wrote at the beginning or at the end?
I had it in my mind at the beginning, but I didn't write the book in that sequential order. Because I went at the book a different way, saying I want to first get people excited about the application and say, okay, here's where you use it. All right. Now, if that's all you ever read, that's fine. You've got that piece. But now if you want more on how it all comes together, so that's why that came out kind of later. Again, the outline being flexible is key. Yes, sir.
Did you talk anything about distributed energy resource management? And I know you mentioned batteries and that sort of thing,
Yeah.
but even thinking about how do you go and manage all the different loads inside of a building, and that's an evolving idea that they're going to start to offset the load from the utilities, and how might that be controlled?
Yeah, there's a section in there on demand control ventilation, which is similar to that, but then there's also other sections on microgrids and giving back and taking from the grid. And it doesn't get to a very technical detail level. It just says, hey, this is, a big activity that's going on inside buildings today.
You see that happening. I think I was in a high rise in Boston last year, and all the apartments were here. Do you see that someday they're going to, I could have demand response in my apartment and different ones within the building there, and the building's going to somehow manage that? Or get involved in that?
Technically, it can be done. The problem is that the buildings aren't set up that way. So you've got a HVAC system that's controlling an entire floor. You can control the temperature to some degree, but getting right down to demand control ventilation per unit may be a little difficult. So one of the things we're struggling in right now, especially Washington, my company is based out of DC, so most of our work is there. Your grandson must have scored a goal in a hockey game in the beginning. But one of the mayor, like it or not, doesn't matter, issued an order to Biden a couple months ago saying, look, either force the federal workers to come back to the office, or we're going to have to start converting these office buildings into residential units. And her claim was we could put 300,000 people into buildings if you're not coming back to the office. Well, we said to her, that's a great noble effort, but you don't have bathroom stacks inside buildings, right?
Yeah.
So just that's problem number one. And if you can solve that, you're redoing the whole building anyhow. So that's the problem, is the buildings aren't set up to handle what you're talking about in most cases. Yes, sir.
Do you feel like, I guess your model is going to be eventually be integrated in how homes are designed, or like, there's definitely a big gap between like the physical, how we think about building architecture and stuff, and then future of IoT, right? How we get a builder to integrate those things. I don't know, what's your thought on that?
Yeah, we're actually coming the other way.
Okay.
So we're taking what's been done with smart homes and using that logic and that thinking to apply to smart buildings. We can, but from a cost efficiency standpoint, I can't afford to put these in every home. They're $20,000 units. So Google, and then I can't compete against Google and those types of Amazon. But they've come up with a standard, and it's in the book, and I can't remember the name of it now, but they came out earlier this year. Matter 1.0, which is basically the home automation standard and connectivity standard, where they're all going to be on the same platform. So they're kind of solving their problem we were talking about with buildings. I don't know if that's ever gonna go in the buildings. I haven't even looked at it.
No, no, that's meant for building scale.
I don't think it is. Yes, sir.
Are you interfacing any of the data you're collecting with like digital twins or?
Yeah, there's a whole chapter on digital twins. Digital twins are huge from the standpoint of, I'm a big believer in first responders because I did a lot of work with them. But being able to look at a digital replication of that building while you're in the fire truck or the ambulance on the way to the building is hugely important. So you know where dangerous chemicals are stored, you know where other things are. And then having access to be able to control certain things while you're on the way to the building. So shutting off air, right? Because worst thing in the fire is you gotta be able to control the air. So all of that is happening with digital twins.
Isn't it a little slow rolling out digital twinning right now? Just saying, or is it happening faster than I think?
I think it's happening faster than you think. I'm not hugely engaged in it, but everywhere I go, it's tough.
Is it
one of
one
the
of
hurdles I hear.
geometry, or you like modeling energy usage or security or anything?
There's all different levels, so you get into thermal imaging, you know, and measure existing components. Was that company we just mentioned?
Autodesk.
Autodesk, right? They're huge in the digital. That I met with them and the detailed layer that they're going at is just unbelievable. Every single thing will be a digital twin.
It needs to be.
Yeah, and the problem with digital twin is how much money you have.
You spend years doing a decent sized building, you know.
But you know, we've done some thermal imaging in buildings in DC. And you get a company comes in for 2 days, they walk down the aisles, they get a pretty good 3D replica, put it into a CAD drawing. You know, and away you go. Now, you're not getting all the detail, but you get something.
So when we talk about digital twin, I like to learn from you guys. We're not talking about one, but we are talking about 10, 15, 20, depending on what things you are trying to investigate. Is that correct? Or one twin can do it all? Because ultimately it's a replica of physical abstract.
They're still very much specialized.
It's still specialized.
Like I said, that Autodesk is the closest thing I've seen to a fully integrated one.
They build the newer buildings that are being built right now, they basically build kind of a digital twin of the infrastructure of the building, but then you need the HVAC guys to have their own overlay on top of it, and the electrical guys to put their overlay on top of it and everything.
Yes, once it's all together as one, it's like if you open a wall, there's so much stuff you can't tell what's there, so you gotta split it.
So I'm just wondering that people create libraries of this thing, like electrical system, hydraulic systems and all of that, and you pull it together and
It will get there. It's a little bit with IoT right now. It's starting to be integrated together, but it's still a lot of different systems that optimize the power consumption, that optimize the HVAC system, that optimize the lighting, that optimizes. But something that looks at all the parameters and say, what if I adjust 5 different subsystems to optimize the overall building? It's slowly getting.
And picture, you know, a traditional blueprint drawing for a building. If you're looking at it, it's 45 pages, electrical, plumbing. Yeah, all they've done is digitize that now, so.
But everybody's looking at it. Okay, and they all see that it's something they're working on, but I haven't found anybody that was giving me a date of when it's gonna be over.
I imagine Chat GPT was.
That's all old data.
Yeah.
ChatGPT doesn't know anything new. You ask it about any of this stuff and it'll tell you exactly what from 2021.
Yeah, it's
Well,
2 years,
used
3 years old.
Yeah, but I think you did the last GPT, you better know what you're talking about because sometimes there's big mistakes.
I'm avoiding it like the plague.
So blueprints and digital twins always come after the building is already made. Have they done anything with like 3D printing? And I know in like homes they're starting to 3D print homes, while the electric and ventilation in there. Have they done any of that on a building scale yet?
3D buildings?
Yeah, well, no, actually building the building with a 3D printer.
Yes, oh yeah.
So everything's already in there, they just put the schematics in.
Yep, actually, I got a section on that in chapter 14.
There's a local company doing it,
Yeah.
and it's still in the early phases, they've only done a few buildings locally. But yeah, it's really interesting, but once it starts ramping up.
It's coming, they're doing there's a company in Austin that's doing a lot of homes, especially for
Keep
homeless.
an eye on the IoT meetup site because we'll have somebody in the next couple of months.
They'll
I'm
get-
getting another company in there.
I'm saying that.
Oh, same, oh, I know, that's really.
But, didn't talk about it tonight, but another part in here is all about IoT and construction. So there's a lot of IoT being used during the building of the building for project management, for security, for safety. Exoskeletons are becoming big. Exoskeleton. So I need one for my knees.
I'm doing a LoRaWAN IoT building project where we're putting load sensors on cranes and tool sensors in toolboxes.
Yep.
And when the tools go in and out, they get checked out, tools do, but they don't get checked back in. So weird. So weird.
Keep checking in my pocket.
And then for cranes, what happens is you might have 3 or 4 cranes on a big site. And the foreman or whoever's running it, when the cranes are done, they're supposedly staggered, so they'll, some of the cranes go away and other ones stay for maybe HVAC units. And cranes are staying on site for way longer than they should. So that's why we're putting strain gauges on them to see which ones are actually lifting something other than the toolbox at the end of the night. Which is void of tools, so weird. We're using LoRaWAN for that.
I thought it was lifting up the generator to hang.
Yeah, exactly.
Blowing away. Other questions, comments? Yes, sir.
Do you see any change in the compliance landscape that would force adoption of smart buildings?
I do. There's quite a bit right now on the energy side, right, which is forcing.
Your 3 favorite letters, E, S, and G.
I see, I already forgot them. Yeah, ESG is driving a lot of that.
So that shift, shifting towards the ESG use cases versus the regular ones, that would be all. And would adoption be like everything together?
I think it's coming together. But with the ESG, you're getting into building materials and windows, and energy management, right? Solar panels, energy give back to the grid, daylight harvesting, all those things are being almost forced into buildings now. And it's the way that they're doing it is it's not like a wall, but if you want to get your building approved in this part of the city, you're going to need a lot of that in the plan. So may not be code quite yet, but they also may not approve your building.
Energy is a big thing, but in certain parts of the US, even water consumption as well.
Yeah, water is the number one, flooding buildings, number one insurance.
Water is also the #1 use of electricity. Pumping, purification, cleaning, water is the #1 user of electricity. So
in certain parts.
It's tied together, right?
In certain parts, I want to know exactly what you're using and what you're using.
But Divesh, 25 countries have mandated ESG initiatives. 36 public stock exchanges. The US, the NASDAQ and it has not mandated anything yet. But 36 public stock exchanges have mandated ESG initiatives. And you talked about how the REITs are and the building are beholden to finance.
Yeah.
There's actually 17 green bond initiatives out there within these stock exchanges right now. That are forcing ESG down this road. So
Then that's a good point. The other way that buildings are getting funded, the funders are mandating that a certain level of carbon, reduction or energy efficiencies.
New York City has local law 97, which is imposing a certain kind of carbon levels and emissions. And they're going to submit data every year. They got to hit a certain level at 2025, a certain level at 2030. Boston's got something like that, and Chicago's got something too. Yeah.
Right. And that's where we see the IoT devices helping because they can collect that data put it through the network, do the data analytics. Right now, a lot of that's still handwritten.
You have to control what you cannot measure.
Yeah.
Just trying to remember what that.
All right, are there any more last burning questions that we want to do here in front of the group? Because we can always take this conversation out to the bar.
Like, who do you think your book is kind of tailored for? So if you're a CIO, a director, engineer, how would you?
Yeah, I mean, that's a difficult question when I was writing it because it's trying to provide a basic overview for any of those groups, right? But it's, if you're an engineer, you're not gonna learn how to engineer
Okay,
a building from the book.
okay,
But if you wanna know the different parts, again, when I started, it's how do we bring these 5 different communication networks so that they can at least talk to each other. I'm not pushing, but if anybody's interested, I do have some books. Welcome.
Free autographs, right?
Free autographs. No, those autographs are $35.
Let's give Harry.
But thank you for, thanks.